Right, let's have a look at the second part of ConvEx. This is the analytical reservoir simulator, and it's based on this boundary element method. So what you see here is a region that I drew around this well here with the yellow dot. And I'm going to show you a small video, and then we're going to do a live example using ConvEx. So let me click on play. So here I'm going to do a simulation, and you're going to see it takes some few seconds to get the simulated data in black versus the actual in red. This red data, this drawdown response in red, this is from part one. Okay, and let me get my pen. Right. So the aim of the game now is to use this drawdown response or the convolution, this derivative in red, to try to model the reservoir. Okay. The parameters you'll have to play here to match this first part. This is the wellbore storage or the fracture half length. Okay. This part here is the skin, and this part here is the permeability. Oh, sorry, don't know why it does that. So if you increase the permeability, the black line will move down. And this part here is the distance to the boundary. So for this particular simple example here, we need to move this black line towards the right. So we need to increase the distance to the boundary. Time is linked to the distance. As time increases, the distance increases. So we need to increase the distance to the fault to match this red response here, to shift the black simulation towards the right. Let me remove this annotation, discard, and do it again. There we go. Right, so here I've got this reservoir region. I'll do a simulation with a right click. It takes some few seconds. I can see simulated response in black versus the actual data in red. So now I can just change the node, follow the fault on the seismic, do a simulation. It takes a couple of seconds. You can see that now we're getting closer to the solution. Right? And it's an iterative process. So I create some new nodes. You can see it's very fast to get some quick solutions. All right, so now I can match the derivative. The derivative is a great tool to guide your simulation, to guide your history matching process, right? Because as I show you, the derivative is affected by some few parameters, permeability, up and down, and if you want to move to the left or the right, this is the distance to the boundaries, right? If you want to move towards later time, you need to move these nodes further away from the well and you can follow the faults. Simple as that. And now you can check also the match with this black line on the pressure data. Here you can see that we cannot match the production, and this is because of the skin, right? We overestimate the flowing pressure and we need to increase the skin a little bit. The well is fractured, so you can see here I can change the skin from minus 4.8 to minus 4.6 and increase the skin, and now I've got a better match on the flow. Let me go back. Here we go. Now I've got a better match on the production period because I increased the skin slightly.